Question 1 is all about logic. We are provided with two statements, P and Q, and we're asked to complete the remainder of the truth table. So first of all, we're asked to complete the conjunction P and Q. So for P and Q, this is only true if both statements P and Q are true. So in the first one, we've got P is true and Q is true, so therefore that's true. In the second line, only P is true, so therefore that's not going to be true. Third line, only Q is true, so that's also going to be false. And in the final line, neither of them are true, so that is also going to be false. The fourth column then is the negation. So it's just going to be the opposite to whatever we've got in column 3. So here we've got true, so this is going to be false. Here we've got false, this is going to be true, etc., etc. In column 5, we've got not P, and column 6, we've got not Q. And in the final column, column 7, we are asked to complete the inclusive disjunction not P or not Q. So this is saying, do we have at least one of not P or not Q? So if we're looking at the top line, do we have one of not P or not Q? No, so that's going to be false. If we look at the second line, do we have at least one of these two which is true? Yes, not Q is true, therefore the statement is true. In the third line, do we have at least one which is true? Yes, so that's true. And the final line, do we have at least one? Well, here both of these are true, and that also counts. So we should end up with this column here. Part 2 then, state whether the compound propositions not P and Q and not P or not Q are equivalent. Well, remember that the way to check whether or not two compound propositions are equivalent is to look at the truth table. So if we're looking at not P and Q, so here we've got false, true, 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 and then here not P or not Q, we've also got false, true, true, true. So because they are the same, we can conclude that they are equivalent.